Hello friends. So as we move forward with the same chapter of work energy and power, we have this problem right now to be solved. So we have seen the cases of a string. We have solved different examples that if an object is attached to a string, then if the string is elongated or even if the string is compressed, then what is the physics that is actually taking place, and accordingly what motion gets induced in the object. And we have seen of vertical motion, free fall under the effect of gravity as well. So in both of the cases we found that it's basically the game of potential energy that actually plays the role. And as per the potential energy, accordingly the kinetic energy changes and we just solve system equations. So there's another example considering string as well as gravity. Now it's very simple problem. Why actually I wanted to discuss it with you people is that in exam you can expect problems like this. So we'll just see what are the basic ways to solve this problem, in what direction you should actually move, so that just in 2 steps you could solve such problems. So here at the top, it's a 2 meter height from the ground. A string whose spring constant is 100 Newton per meter is attached with a block of mass 100 gram. Now it's a horizontal level base. So then the problem says that somebody pushes the block against the spring. So basically what will happen? You are going to compress the spring. The spring will be compressed, means the spring will gain some potential energy. So the spring is compressed by 5 centimeter. So it is first compressed. So till the point it is compressed, means if I draw the picture here, so this is 5 centimeter. So at both the points, point A and point B, the kinetic energy of the block is 0. Block is not in motion till that point. So whatever work one needs to do in taking the block from A to B, that amount of work is basically stored in the form of potential energy in the spring. Because if potential energy is coming in the spring, it must be coming from some source. So what is the source here? Source is the work we need to do in order to compress the spring. So whatever work has been done, the entire amount has been just transferred to potential energy, because there is no kinetic energy component. So whatever work done, just transferred to potential energy. So we can calculate the potential energy there. That will be half kx square. That is equal to half into 100. And x, keep in mind, is 5 centimeter. It means 5 by 100 into 5 by 100. So basically 25 by 200 or 1 by 8. This is the potential energy. Now we just remove our hand. When we compress the spring, we must be applying some force. Suppose we are just pushing the block. We have pushed it to 5 centimeter and then we remove our hand. What will happen? Because of this potential energy, the spring will push it back to its natural position. Very easy. So when it will push it back, it will definitely gain some kinetic energy. So by the time the spring comes back to its natural length, means at the end of this horizontal bar, till that point, at that point you can say the potential energy will be again 0, because the spring is in its natural length. So if the potential energy is 0, it means potential energy has been transferred to what? To kinetic energy. Because when the object is coming back from B to A, there is no external force. It means during the path from B to A, delta E is 0. from V to A. So when it comes from V to A, the potential energy gets slowly transferred into kinetic energy. So initially potential energy was 1 by 8 joule. So finally kinetic energy will be what? Again 1 by 8 joule. Because the spring has attained its natural length, so its potential energy is 0. So entire energy has been transferred to kinetic energy. Because our final E, that is constant. Total energy is constant. Why it is constant? It is constant because from path B to A, there is no external force. So we have already learned that when there is no external force, energy remains conserved. Now this is the kinetic energy. So it can be equated to half mv square. It means 1 by 8 equals to half, mass is 100 by 1000 in kg, into v square. So it means v square equals to 10 by 4. So what is this velocity? What is the direction? The direction is totally horizontal. So at this point you see this velocity is horizontal. So basically it's Vx at that point. Now if somebody asks that just at this verge, at this edge, what is the Vy? What will we say? Object was moving along horizontal. There is no displacement along y. It means along y, no velocity has been gained. So till that point, Vy is 0. Now, because it has some velocity, it will come out of the horizontal path. It will start free fall. Now, under the effect of gravity, it will gain the path like this, half of the projectile path. We have already seen projectile in kinematics. So here in our question, the problem is starting from this point and it will end somewhere here. At this point, Vy is 0. So whatever velocity was there because of kinetic energy, the entire velocity is Vx. So Vy is 0. Now we have been asked, but what is the horizontal distance it will move while coming to the ground, which is 2 meters below? It means simultaneously now we have to solve motion along y-axis and motion along x-axis. And what is common with us? That is time. We have seen all these things in kinematics. So we have time in our hand. It means we can apply equation of s equal to ut plus half a t square. With x, ux, ax. Now how will we get time? Time we will get by sy uyt plus half ayt square. Now in x, this part is 0 because there is no horizontal acceleration. But in y we need to calculate it. So sy is 2 and what is uy? That is 0. There is no vertical velocity initially. So half of ay is considering it 10 t square. So t square is basically 4 by 10. Now we can easily put this value here. So Sx will be Ux, which is effectively Vx. Now to calculate Vx means root under 10 by 2 into t. T is 2 by root under 10. It means it's 1 meter. So in coming down 2 meter, it will move a distance of 1 meter in this form. So this is the way we need to approach. Since I was explaining you, so that's why I need to explain every step. Otherwise to you, it should quickly come in mind that this potential energy is going to convert into kinetic energy. And this kinetic energy is going to bring velocity. Now the important thing to keep in mind is the direction. So the velocity at this point would only be horizontal. Now when it will come into air, when it will come under gravity, then it will keep on gaining vertical velocity. And what are the distances are given. So we just need to solve this equations of basic Newton's equation of motion. And the way we have solved earlier, the time we need to calculate from one equation and we need to put the value of time in another equation, and ultimately we will get the solution. This is 1 meter, that's the answer. So I hope this is clear. So let's move to some other problems. Now let's do another basic problem, but filled up with an important concept. Now this is the point A, this is the point B. Its height is 1 meter and its height is 0.8 meter. So initially at time t is equal to 0, there was an object placed at A. Somebody give it a push, a very gentle push. A push, you can imagine that something which is just a velocity slightly greater than 0, almost negative. So the push was sufficient enough because it's a downward slope surface, so that push just gave motion to it, and the rest of the thing was performed under gravity. Under gravity, its speed must have increased till the point, then something decreased, then increased, then finally decreased, and it is found that this object finally stops here. It doesn't move further. So why does it stop? If someone says that this is a smooth track, if someone says that this is a smooth track without any friction, and you are asked that is this statement correct, that if an object starts at the point A, which is 1 meter away from the ground, and then suddenly stops at point B, which is 0.8 meter away from the ground, and the path it has traversed is totally smooth. So will you agree? So let's see whether we should agree or not. So if the path is smooth, means no friction loss. So initial kinetic energy is 0. We can neglect that little push because that's almost 0. And finally, kinetic energy is obviously 0. Now, if there is no friction, then there is normal force acting at the object at any point. But is this normal force of any importance? Importance, I should not say, rather I should say that is this normal force doing any work? Because importance is there definitely, we will see it later. But is this normal force doing any work? No, it's not. Because at every point of time, the direction of normal force and the direction of displacement is perpendicular. So it doesn't perform any work. So work done by normal force is 0. Is there any other force? The only thing left is your gravity. Now if we consider potential energy apart, so gravity becomes a part of the system, so it becomes an internal force, and so when it becomes an internal force, we will not consider it in the external force, and so we will eliminate it from the work energy theorem. Actually, we can even include it in the work energy theorem as well, but the thing to understand is here that we need an external force outside the system because it's a multiple position system. So, if surface is smooth, gravity is a part of the system, it means net energy should be conserved. So, del E should be 0. But do you think that del E in this case is 0? Del Ke, that is definitely 0 because 0 minus 0 is 0. But is del Pe 0? No, it's not. It's very obvious. Initially it is at a height of 1 meter. Now it's at a height of 0.8 meter. So the height is not same. It means del Pe does not equal to 0. So in that case, del E is not equal to 0. So in that case, there must be some work done. There must be some kind of external force. So what force it can be? The only option left is that it can be frictional force. So frictional force is playing some trick here. So one thing is clear, that this surface cannot be smooth. It's a rough surface and it's not horizontal or vertical. It's a very random surface. Now we should not get worried looking at this surface. It's pretty easy. How? Suppose we are asked to calculate the work done by the frictional force from point A to point B. So definitely we cannot calculate it in the traditional way, as it will get too tiring integration. The easy way out is, let's apply work energy theorem. Del K is 0, del P is not 0. For what is del P in this case? If object is of say 1 kV, so mgh, mg del h. So 1 into 10 into 1 minus 0.8, that is 0.2. Let's say make it easy, let's say half kg. In that case, del P is 1 joule. If this object is of half kg. Now del P is 1 joule. It means the potential energy change is 1 joule and kinetic energy is 0. It means del E is also 1 joule. And what does it mean? By work energy theorem, the change in total energy of the system is equal to the work done applied by the external force. And work done by normal is 0. So it means this is the work done basically done by frictional force. So sometimes when you find a very tedious path and you are asked to calculate the work done by friction force, just keep in mind that you are not supposed to calculate that tedious path. Rather, you have to apply work energy theorem in some way or other, and from there you have to effectively calculate the work done by frictional force. So we took out the easier way. We calculated the change in potential energy, and that is nothing but change in total energy, and it is coming from the frictional force work. So whatever work done by friction force, that is 1 joule, and that is equal to change in total energy. So I hope these two examples must have been clear to you all. Thank you.